This problem is from the book. Yeah, and it is from a problem from the book. So, but I would say it's a good example of the sort of thing that we might need to know. I wouldn't know anything about that. Okay, so what is n? N is 4. And the instructions for this are to determine V out. We see the dots are on the same side, so we don't have to add a minus sign to our equation. We know Zn is going to equal Z load over n squared, which is 32,000 over 16, which is 2,000. So Vn, I can use voltage division on that, and I can get that Vn is 12 angle 0 degrees times Zn over Zn plus 1 kilo ohm. Our Vn is 12 angle 0 degrees times 2k over 3k our Vn is 8 angle 0 degrees. We know that V out equals N times Vn. And so V out equals 4 times 8 angle 0 degrees. Our V out equals 32 angle 0 degrees. Is that it? That is it.
How do you know V out is equal to N times V1?
I know that because
So V out is V2.
it's in parallel.
So
Yes.
it's in parallel.
Yeah. So it's yeah, it's because it's in parallel. It is the same as V2. I don't have anything else for you besides that. Yeah, everything over here is the same voltage. All right. So, seeing is how I might have seen that problem in the book and perhaps in the same place where y'all might have seen that problem. I thought I would get other problems in the book that were close to that problem and that we would work those just because it seemed like a good idea to me. So that's what I did. Because that's what I would do if I had to take this test. Wait, is this the one I just did? Yes. Okay, now we're adding a capacitor. So we're making it tiniest bit harder, but not by much. So we do need to know that omega is 1,000 radians per second, which I think I did not put that on the handout. I think I just, did I give directions to this problem? Or did I just put the circuit? Okay. Okay, you do need to know that omega is 1,000 radians per second. And dot's still on the same side. And so Zn is going to be the same as it was last time, the same as Z load over N squared. And we got that it was 2 kiloohms last time, and it still is. But this time when we do voltage division, we have more stuff on the left-hand side. So Vn will equal 12 angle 0 degrees times Zn over 1 plus minus j over 0.5 times 10 to the negative 6 times 1,000 plus 2,000 or 12 angle 0 times 2,000 over 1 plus negative j 2,000 plus 2,000, 12 angle 0 times 2,000 over 2,001 minus j 2,000. Oh, this was not 1, this is 1,000. There's 1K. That makes a lot more sense. That should be 3,000. And I get that this equals 6.65 angle 0.588. That's not right. I'm in radians. What is it? Did you have a minus J2000? Let me get myself into the degrees. Yep, That's what I get. Okay, so that is Vn. We know that V1 equals NV2, and we know that V2 is going to equal V out. So I got that backwards. V out, or V2 equals NV1, which is V out equals NV1, or V out equals 4 times 6.65 angle 33.7 degrees, or 26.6 angle 33.7 degrees volts. Any questions before I go on to the next one, which was also just kind of right there in that same little group of problems that I thought would be worthwhile to do? So this one, we are supposed to find the complex power supplied by the source. All right, so what is N? N is 2. What is ZL? 16 minus J8. So we know that Zn equals K, 16 minus J8, K. So we know Zn equals ZL over N squared, or Zn equals 16,000 minus J8,000 over 4.
So that equation doesn't become negative, it's only the voltage and current.
Correct.
It's just not
Well, and you can remember that because if it was, let's say it was purely resistive, it doesn't make any sense to talk about a negative resistance. So it's only the voltage and the current. So Zn equals 4,000 minus J 2,000 ohms. All right, so no, I put thousands in. So now if I add up all the impedances on the one side, I can say Z1 total is 1,000 plus Zn, or Z1 is 5,000 minus J 2,000, and then I can get I1. I1 equals 24 angle 0.
You say 5,000 minus J 2,000.
How did I say that?
Yeah.
Zn was 4,000 minus J 2,000
Never mind.
over 5,000 minus J 2,000. Where's my calculator? And so I get 4.45 milliamps. Um, oh, that is right. I just was reading it wrong. Okay, so I get I1 equals 4.457 angle 21.8 degrees milliamps. And I'm supposed to be looking for the power supplied. And so I now have the current that's going through the voltage source. And so my power is going to be 1/2 V times I conjugate. So that'll be 1/2 times V is 24 angle 0, and I conjugate is 0.00445 angle negative 21.8 degrees. So 54 angle negative 21.8 milli VA, or just 0.054 angle negative 21.8 degrees VA. You have a question? Any questions? All right. I'm going to stop this and save it before I do the next one, because the next one's a little harder.